Now the problem that I have, besides just owning this sander, is that these rollers, in-feed and out-feed rollers, both of them, this one has already been removed, are loose. And they also press down much too hard on the work, almost stopping it when you try to feed it through, especially over on the outfeed side. So I'm going to replace these rollers, but I've also found that these brackets right here are a problem. They are hogged out, they're a mess, and I have to replace those. And there's a little trickery that I have to do to replace them. And I thought I'd share with you what that is. Nothing too serious, but some things that really need to be considered. So you can see that the end of this bar is very, very badly worn. In fact, the whole bar, from just the friction of rotating on the conveyor belt, this is about 15 thousandths of an inch thinner than it should be. But this and this shoulder that's on here, this is supposed to be 3/8 of an inch thick, and as you can see, it's worn down pretty badly. I doubt that that's any more than 1/4 of an inch at best. So it needs to be replaced because it just slops in its mounting. And what happens is, when you try to run material through the sander, it hits this on the outfeed side and it doesn't want to raise up. So we're going to try and fix that. The other problem is that this is the bracket that shaft mounts in, that roller mounts in. It goes in like so. And as you can see, the slop in that is just awful. And look at how it's been all hogged out. Now this is an interesting piece. It's very thin, and you would think, why didn't they just make it thicker, or why didn't they put an oilite bushing or something in there to keep all of this working for longer? First, I should say that to get to this point right here, this has taken 20 years. So maybe I was expecting too much. But this piece is thin because it has to be. There isn't a lot of room down in the sander to accommodate this. And you notice this little flange that's been pushed out when they manufactured the part. That was to give this a little more surface to ride in. I was going to replace this with a larger hole and put an oilite bushing in it, and realized this morning that that can't be done, because when you put a narrow piece of material in one side or the other of the sander, the bar does not raise evenly. And so if there was a bushing in there, it would put undue pressure on the bushing and torque on the shaft, and I'm sure that would just create all kinds of trouble later on. So I'm going to rebuild these, 4 of them, and it includes, when it's mounted, it's bolted in with this just 1/4 inch bolt. Sorry for my fingers. With this 1/4 inch bolt, but this bushing is placed inside the sander to act as essentially an axle bolt. So the bolt comes from the outside of the drum sander to the inside, and this rotates on it. And then this larger shoulder is what accommodates that spring, which, sorry, got that upside down. That spring goes in there like that. And that has to be this size to accommodate this diameter. But you see how the spring's much larger, and that's done because when that spring compresses, its diameter decreases. So they did do some thinking, but it's caused some trouble for me because I don't have steel this dimension and can't get it for several days, so I'm going to try a couple of tricks of my own. So the first thing I need to do is make something to get this bushing a little bit wider. You can see the very top of this, that shoulder that's on there. That's not quite long enough. It doesn't extend far enough into the drum sander. It does to accommodate this, but I'm going to rebuild this in 1/8 inch steel. This is just over a 1/16 of an inch. So I'm just going to make a ring that's going to help me extend this, and that's necessary because when this bolt passes through it and you put a nut on the other side, it has to meet that bushing, excuse my fingers, it has to meet that bushing before it meets this piece of steel, otherwise it's going to lock it down and keep it from rocking as expected and as designed. So we're going to go over to the lathe and make those little bushings. So now I'm fabricating these pieces of steel, which will become these brackets right here. I'm making mine a little bit wider. I have a reason for that. I hope that doesn't backfire. But assuming that everything is good to go, here we are. So on the milling machine, I've set up this stop right here. This is just a nice stop rod that I have. And this way I can register each part into the mill vise in exactly the same position. I have my digital readout set up. Now, I'm not perfect with this thing. I'm really just learning to use it. But I've already zeroed the end of the part and I've zeroed the edge of the part. So I have the drill, the center drill, over the center of the piece widthwise. And my first drilling position is 750 thousandths down the x-axis. So we're set there and we're going to drill that, and then I'll move to the other two positions and drill the other two holes. Okay, I'm good to go with that. So now my next position, rather than zero this or try and save all of this data, my next position is at 1 562 thousandths of an inch. So I'm just going to move there. You really don't have to worry about these two numbers. They're pretty fictitious. So now we're ready to drill again. And I'll do that with a third hole, and I'm going to center drill each one of these, and then I can finish them on the drill press. So there's the 4 pieces, soon to be brackets, if you will. They're center drilled in all the right positions, and then end of the day today, but tomorrow I'll put those up in the drill press in a vise, and I'll open those holes to each one of the proper dimensions. In this clip, I'm turning the nylon bushings. I'm ready to make the infeed and outfeed rollers, so I've chucked a piece of 3/4 inch carbon steel into the lathe and put some bluing on it here so that we can, layout blue that is, so that we can see what we're doing. And you can probably see right here, I've set a stop so that I'm not guessing at that shoulder. This is not machine critical, of course. This is, you know, the tolerances are such that you could measure this with a ruler. So it's not real critical, but we want to be consistent so that when we're done, the shoulder is consistent. So we're just going to turn that down a little bit, and we're going to go to 3/8 of an inch. And I'm just feeding this by hand. I will do a very slow pass during my final pass to get it absolute and to improve that finish, and I'll do that with the lead screw. So what I did in quick review here is I replaced these nasty parts with these parts, and they are front, outfeed, and infeed sides. They had to differentiate between the two with this curve here. This accommodates the framework of the machine. But I made 4 of these parts, and I put a nylon bushing in them because my thinking was that I can easily replace the nylon bushing if it wears out. I can pop that out of there and make a new nylon bushing in 5 minutes. To make these parts was a little more time consuming. That included having to make that little bushing right there, which extends this capstan that's inside the spring. You can see the little bushing right there. That's so that when this is all bolted in, it doesn't, the nut doesn't come up tight against the frame or the piece and keep this from rotating. So it just works out a little easier. I think all of this should work pretty well. I've also made this bracket wider than the original. And I think it's important that I mention that because these narrower brackets allowed the roller to drop a long ways. So much so that when you feed material through, it was hard to get it into the sander, and sometimes it would hit the outfeed roller and stop and cause the sander to put a snipe in the work. You've probably experienced that with yours. So there's quite a lot of pressure on these torsion springs. I'm surprised that they made them that stiff. So I found that I had to mill a small little thing in there. Can you see that all right? I had to put a little cut in there to accommodate the end tab of that screw. Otherwise this was too thick to hold on to it. And here is the new roller with the end turned on it. This was easy to do. I am not a skilled machinist by any stretch of the imagination, so this was not too hard to do. So now I'm going to assemble this thing and we'll give it a test run and see if it works. A couple of additional tricks I found when it comes time to disassemble all of this stuff and reassemble it. Disassembly is pretty straightforward because it'll all just fall apart in your hands eventually. Take the end panel off the machine, that helps on this side. But these capstans here, if you will, and spring devices, those all have to be assembled, and the brackets have to be assembled onto the roller before you put it all in the machine, and that means that it has to be done on both ends. And it's kind of a wiggly process, but you can eventually get the 1/4-20 bolt that holds all of this together. You can eventually get that through there and get your washers and nuts on there and so on. But the big trick that I found, in order to get that spring right there to come to tension, you're best off to pull this bolt completely. Just take it right out of the way. And then when you reassemble this and get the nut on it, the tip of that torsion spring will be back here somewhere behind that nut, and you just keep threading it in and threading it in, and as you get closer you'll be able to push that spring back out of the way with a narrow screwdriver or something, and you'll be able to get that together. And to do it, the bar has to be up about as far as it can go. So I put a rope on this thing and I can just pull it. You can see I just pull it right up out of the way, and I wrap it over here and I can clamp it right there with a, one of these single-handed clamps. It's just an easier way I found of getting it back together, because it can be a pain, and it's, you got your hands down in small places. So hope this has helped, and I'm sure that these machines, they've been around for long enough. I'm sure I'm not the only one that's had all of these wear out and give up. So I hope this gives you a leg up on how to repair all of that. I discovered on reassembly that the ends of these brackets are actually too wide. The problem is that they drop down below the roller itself, which means that anything on the open end of the sander if you pass it through and it's outside the sander, it's going to hit that bracket. So that end of it at least needs to be reduced to 3/4 of an inch or slightly under, so that materials wider than 18 inches can be passed through. Other than that, the project worked very well. So the test run that I just did was on this piece of hard maple. It's 3 inches wide or so. Finish came out nice. I didn't see any bouncing or anything that looked problematic. There's no sniping. So I'm under the assumption that my kind of added engineering was correct enough so that we're still functional as we should be. I do want to point out that right here, I don't know how well you can see that, but I'll see if I can raise the roller so that you can see it. I have milled a tab out of that corner, about, I'd say, 1/8 of an inch. And partly because my bracket is wider, so I needed at that point to more closely approximate the original, but mine is still wider at that point to keep this bar up a little bit further when nothing is happening. It was down so far, as I mentioned before in the video, that things would jam on the outfeed side, and I think this has pretty well eliminated that. I'll try a couple of instrument tops or something that wide, and we'll see a little bit later on. So I hope this video showed you something about how you might go about repairing the same problem, because I'm sure you probably have it if you've got one of these, and if you don't, you will. If you have any questions about this, or if there's something that I seemed vague about or didn't answer, feel free to contact me through YouTube or contact me through my website, ledouxguitars.com.